Chimere is a distant planet. It is defined by waves of life brought from Earth and set free to evolve independently in this new context. The indigenous life of the planet, swarms of microbes called magic by the people who live there, are what harvest Earth organisms and make copies on Chimere. As the asteroid which concluded the Mesozoic never struck Chimere, dinosaurs remain the dominant terrestrial megafauna.
A vast inland sea, the Trayam, carves apart the territories of the known world. Most of these waters are surprisingly shallow, averaging less than 100 feet deep, with a few deeper channels throughout, thanks to the currents which cycle in nutrients from 3 mouths to the south and 1 to the north. A great majority of this shallow inland sea is a seagrass meadow. The meadows make up such a density in this sea that from the sky it can look green. Although as much as 80% of the Trayam Sea is meadow, and the braiding river channels make up deeper waters, one other habitat can be found, especially along the coasts and edges of the current channels: the coral reefs. On Earth, reefs make up less than 1% of ocean floors, yet are home to a staggering 25% of marine species diversity. This percentage doesn't bear out in Chimere due to the biodiversity of the Great Seagrass Meadow, with this habitat at a quantity with no Earth analog, but the reefs are still home to a tremendous number of species. Most coral species grow in waters less than 50 meters, and there's plenty of ideal habitat for them, even if most of the meadows are seagrass. Reefs of Earth come in 4 common forms and numerous minor types. The most common is the fringing reef. This grows along the coast. They build upon themselves, generally remaining below the lowest tide. These are very common in the inland sea. In older forms, the sandy and coral interior often erodes away, making a shallow lagoon. This latest form is quite similar to the next type of reef, barrier reefs. These grow up from rock, usually along the transition between shallows and open water. There are many barrier reefs along the current channels that cut through the meadows and offer a degree of insulation and separation of the deeper habitats and interior meadows. The largest reefs in the known world is the barrier reef along the coast of the Eastern Crescent, stretching for nearly 2,000 miles of coast with very few breaks. Platform reefs are the third type and often grow amongst other forms. These range from small columns of coral a few meters wide to independent platforms many miles across. The largest is the Deadwind Cog, a circular platform of coral over 100 miles wide. The cog's tallest portion breaks the surface, and many sections are only a meter or so below, making it very dangerous for vessels to enter. At its center, it is said to be a great ruin left by the first children, with monsters and a plethora of strange and magical treasures within. Countless ships have been lost in a futile effort to find the hoards. The Kalines say this enormous reef is at the core of the winds, and its spinning is what powers the winds in the inland sea. While this has no basis in recorded fact, it is worth noting that the reef is at the center of the high-pressure cell from which the winds of the Trayam Sea do swell to their lowest pressure zones along the coasts. The fact that the first children built a mighty structure at its core suggests that they also appreciated the position of this reef at the heart of the wind cycle. So far, all 6 assembly missions into the cog have failed, and unless a permit to enter with aircraft is approved, it will likely remain a mystery. Atolls are the 4th type of common reef. They usually begin as a barrier reef encircling an island. As the island erodes, the reef remains, and eventually only the coastal barrier remains around the lagoon. The volcanism which concluded the Tyrant Dynasty 15 million years ago created a tremendous number of volcanic islands in what is today the Great Kaline Sea, and many have eroded to the point of being quite small and surrounded by atolls, making them cays. The Kaleen, especially the Eskadine peoples of the inland sea, are especially fond of living in atolls. The lands offer settlement and enough soil to grow a few choice crops like yam and citrus, while the atoll or key reef both trap an abundance of pelagic fish every low tide and protects the island from strangers who don't know the points of navigation the islanders have either discovered or carved. It is the perfect marine Eden for these seafaring peoples. Naturally, reefs provide an abundance of prey not just for the peoples of Chimere, but for large predators too. In the open oceans, there are countless great and formidable sea monsters locked in an unending battle for survival and supremacy. Some of these leviathans, like Megalodon and the Mosasaur, swim into channels and are the top predators there. In the meadows, the Kurjaku, a mighty theropod so dense it sinks and can run along the grassy sea floor, has established itself as the uncontested monarch of the prairie below the waves. The reefs, too narrow and crowded for any of these giants to navigate, has facilitated the evolution of a specialized apex predator, the Katabo. The Katabo was long assumed to be a serpent, a snake of tremendous size. However, as flippers can attest, it is from a distinct lineage of very derived lizard, the Mosasaurs. In Earth's history, Mosasaurs were the apex predators of marine ecosystems for the later years of the Cretaceous. Their early evolution is still under study, though it appears that 3 to 4 lineages independently evolved numerous features, such as tail flukes and flippers from a crocodile-like lizard ancestor. Great size also independently evolved at least twice with the Mosasaurians and Tylosaurians, while the halosaurs and Plioplatycarpines generally remained small. It has been debated for centuries if mosasaurs are closer to snakes or monitor lizards, and remains unresolved to this day, in no small part because of how convergent early mosasaurs are, making anatomical analysis quite difficult. In Earth's history, the rise of mosasaurs appears to have been connected to a decline in the great pliosaurs. It is tempting to think mosasaurs caused the decline and eventual extinction, but a fragmentary nature of the fossil record makes clarity on this matter challenging. If they did cause the extinction, it is likely only in deposing the last survivors, as many millions of years separate the last known pliosaur and the first giant mosasaurs. In Chimere, their dynasty likely aligned a bit closer to the competition model. A prolonged extinction event on land around 70 million years ago was caused by a cool and arid period, and several harvests were triggered, though the oceans were thriving in these years. The mosasaurs collected at this time, in the transition from the Campanian to the Maastrichtian, were at their prime of size, but also biodiversity. Though not as agile as the pliosaurs, the giant mosasaurs were faster and far more efficient generalist predators. Coming into the picture already large enough to overcome an established niche threshold that held back a lot of other predators meant that they could directly compete with the great pliosaurs. Their takeover was not immediately absolute, and it appears pliosaurs persisted in the polar regions until later in the Tyrant Dynasty, but for the most part the oceans of the Tyrant Dynasty were the age of mosasaurs. As many as 9 clades evolved in these years. The dynastic extinction hit the shallows quite hard, and much of the algal blooms between volcanic spikes and the ash wiping out plankton base of smaller food chains, and many mosasaur lineages went extinct. In the years that followed, it was the smaller mosasaurs that survived, and they faced competition from newly harvested cetaceans and giant sharks, along with other native fauna like encodont fish. Throughout the past 15 million years, the open waters have been an ecological battleground, though the great pelagic catapan-seated mosasaur Motomasaur is generally considered the apex predator of the warm and temperate oceans, with a mix of cetaceans, sharks, and elasmosaurs vying for the niches in the colder southern waters. It seems the reefs have a far less contentious niche. Yes, a variety of sharks, marine mammals, and large fish are the vassals vying for land and title, but the unquestioned king of the reefs is the Katabo, a serpentine mosasaur of the clade Coralliophidae. Unlike the conventional mosasaur body plan, these derived lizards are extremely elongated. The clade as a whole are a long and slender bunch, and alongside their kin, the Katabo does not stand out much aside from size. The phylogeny of Chimeran mosasaurs remains hotly debated. The skull of the Katabo, for example, has many basal traits, leading to some experts classifying them as halosaurines. However, the elevated blowhole is a much more derived trait similar to catapancetids, which are extremely derived and specialized for open water. Catapancetids are usually interpreted as mosasaurians, especially given such taxa as globidens and xenodens, which have very similar diversity in tooth morphology to the catapancetids. The teeth of catapancetids could be a case of convergence, or maybe the skulls of the two converge in an elevated blowhole, which allow the eyes to remain submerged while they breathe. If catapancetids and coralliophids are indeed sister clades, as it is often suggested, it would be a striking case, considering they are heavily diverged along the spectrum of locomotive forms. Ancestral mosasaurs appear to have been largely subcarangiform, meaning the body is generally stiff, and movement was in the back half of the animal as they swam. Catapancetids are tuniform swimmers, trading mobility for an efficient stroke wherein only the tail moves as the animal swims. Catapancetids are extremely fast and efficient swimmers. Their crescent-shaped tail is ideal for the task. On the other end of the spectrum are the coralliophids, swimming with an anguilliform or eel-like stroke. They sacrifice speed and efficiency for mobility. Catapancetids are specialized for rigidity to the point that they have ribs slightly interlocking. Coralliophids can enact a burst of impressive speed and efficiently navigate through coral labyrinths, though they lack the endurance and have a very inefficient stroke, with water passing along most of the body and accruing substantial drag. However, their flukes angle downward at up to 45 degrees in the largest species, which are far stronger angle than most anguilliform swimmers. Their swim stroke is factored into the ontogeny of the Katabo. While young, the Katabo are even more eel-like in their stroke, helping them navigate nooks and crannies throughout the reefs. Adult Katabo, in which bulls have the greater Katabo can reach 50 feet, are obviously not able to swim as nimbly, and the lower angle of their tail appears to reflect this. In juvenile greater Katabo and the two smaller species, the tail tends to be more in line with the body. The reefs offer no shortage of food options. A wide range of fish, shark, marine mammal, mollusk, crinoid, and crustacean call these habitat home. Perhaps in an effort to keep as many options on the table as possible, the Katabo has a very generalist feeding apparatus. The jaws are long and narrow to grab nimble prey, yet the tall blowhole also strengthens in a downward strike. The skull joints are flexible to swallow large prey, yet reinforced for a sturdy impact. Their teeth are uniform pegs, not specialized for small or large game. This versatility is critical to their lifestyle. Everything has to be on the menu, and in an effort to avoid open water where they are both vulnerable to large prey and unlikely to successfully land an attack, they must be able to hunt anything in range. Their nutritional demands are low for something of their dimensions, but they're still endothermic and need to eat most days. The sensory pits at the tip of their snout are critical to navigating their environment. While catapancetids have a sensory receptor all along their jaws, in Katabo it is densely concentrated on a boss at the tip of the upper snout. Vision is also very keen, perhaps more so than in other mosasaurs, as it's easier to see in the shallow waters of reefs, so it's worth a greater investment. and their prolonged tongues are also quite sensitive in how they assess what prey is in the area before narrowing down by sight and touch. While some of their smaller relatives are restricted to reef ranges, leading to a tremendous number of distinct species, Katabo are large enough that they are able to travel between reefs. Males in particular are not very territorial, swimming between reefs to mate and find enough food, where they require more than the females due to being more active and being larger. Katabo are not particularly social animals. While females may willingly share a reef, it is large and plentiful enough, males are far less accepting of each other. In open waters, Katabo generally avoid each other and remain subdued. Mosasaur, Megalodon, and Kurojaku can all outswim and efficiently overpower a Katabo in open water, so even when males are traveling, they are quite cautious. At reefs, however, they are extremely violent. Adults of both sexes are usually covered in scars, and males in particular have such violent duels that killing the opponent is not uncommon. They are, however, extremely durable animals, and surviving devastating injuries such as losing a fin or having exposed bone or organ is common enough that many cultures regard them as the pinnacle of a warrior beast. Katabo will sometimes attack chimerans, and reefs are much more popular with fishermen than open meadows or ocean, though Katabo attacks are usually driven by curiosity more than hunger. Only greater Katabo readily swallow people whole, and they're usually more interested in the bycatch of fishing nets than the fishermen themselves. Unlike Mosasaur, which seem particularly inclined to attack ships, Katabo rarely bother. Perhaps boats simply look too much like other sharks and great leviathans that attack them in open water, so they instinctively avoid larger vessels. Most reefs in Chimere are analogous to our own reefs. Many species of coral and fauna which live around them are from the harvests within the past 15 million years or so it would look familiar at least in broad strokes. The indigenous Chimeran corals aren't lacking in competition, but while the slate was cleared during the dynastic extinction and billions of new polyps were collected in the first few harvests, new corals had a distinct advantage in the inland sea. Corals of Kyrule are much longer lineages than on this planet, including some rugose and tabulate corals which went extinct at the end of the Permian on Earth. There are many abyssal corals as well, with a symbiosis of rugose and tabulate corals surprisingly extensive in the abyss. The most unique corals in Chimere are flea-floating symbiotes of honeycomb tabulate and Mesozoic stony corals. In several open ocean current gyres, air-filled tabulate corals locked together by stony cousins serve as the foundation of a floating ecosystem. As marine gyres are not static and shift due to seasonal changes in the short term and continental shift in the long scale, many of these mats are new, although some are such mats in the gyres, such as east of the crescent, are theorized to have been built up over many millions of years. The largest of these patches regularly known to Chimerans is a 200-mile patch in and near the high-pressure zone, out in the abyss just east of the crescent. There are rumors that a gyre has trapped a massive patch southwest of Aravel, spanning 1,000 miles wide, though this is unsubstantiated. Katabo have been sighted at these floating mats, but it must be said that they are not stationary. There are enough segments that are solid, a rigid structure for their size that would not last in the waves, so an ever-growing chain-like structure formed by stony corals helps maintain the general cohesion, along with the force of the current, though the corals still move and strike and break apart. Not a suitable habitat for a large predator to be in a rattling coral, especially in a storm. When Katabo too appear to be in these mats, it is likely only to hunt along the fringes, although pelagic predators gather to feast upon the bounties of coral fauna in the open ocean, and this puts Katabo in further danger. Below these mats, it is sharks and great fish who are king, and may be many miles between the interior and holes to breathe, though Mosasaur and other air breathers still patrol in search of the many prey species which gather below these floating smorgasbords. While reefs are somewhat overshadowed in terms of biodiversity and biomass by the seagrass meadows in the context of the known world, it is still an important and diverse habitat with tremendous ecological importance. In these reefs, the Katabo is king, surveilling every nook and cranny in their domain with calm patience, ready to strike at anything that dares defy them. Cheers to Glarn for sponsoring this episode. I've wanted to revamp my old Mosasaur episode for a while, and while this was a great opportunity to at least begin that process. Reefs also really haven't gotten that much coverage. Part of that is because the seagrass meadows are both extremely important and don't have close Earth analogs in terms of sheer abundance, so I figured they deserved more attention. But I was glad to have the chance to at least paint a broad strokes picture of what's going on in the reefs of this project and the horrible giant lizard that dominates the habitat. In Songs of the Inland Sea, a subadult greater Katabo attacks one of the protagonists in the short story When Sea Meets Shore, and in the mermaid story Tides of Restoration, I introduce a merman with a Katabo aspect. It's a very important animal in the mythology and folklore of Chimeres, and I'm very glad Glarn sponsored this opportunity. The floating reef ecosystem was inspired by the garbage patches in our own open oceans, primarily those in the Pacific. Unlike in Chimere, wherein these masses are a naturally evolved foundation of a healthy ecosystem, the garbage patches are made primarily of plastic and release countless toxins into the water as they deteriorate. Nature is resilient, and an impressive ecosystem of coastal fauna has already adapted to this pelagic habitat, but it remains incredibly unhealthy for our oceans. Thankfully, a non-profit organization called the Ocean Cleanup is putting forward an impressive initiative to address this ecological disaster. You can learn more about the initiative, and donations would be great if you can help their efforts through the links above. We're part of this incredible world, and for all its resilience, our home would be a lot more pleasant to live in if we keep it clean. Thanks again to Glarn, to my Patreon patrons for your support, and thank you for watching. Cheers, folks!